hacking is an elite profession within the IT field. As such, it requires an extensive and detailed understanding of IT concepts and technologies. At the most fundamental level, Linux is a requirement. I strongly suggest you invest time and energy into using and understanding it if you want to make hacking and information security your career. This lecture is not intended for the experienced hacker. Instead, it is intended for those who want to get started along the exciting path of hacking, cybersecurity, and pentesting. It is also intended not as a complete treatise on Linux or hacking, but rather a starting point into these worlds. In this lecture, we won't go into any one concept in great detail. We'll cover just enough to let you play and explore in the operating system of hackers Linux. We will save more in-depth discussions for later lectures. So let's get started. Unlike when you're working in a graphical user interface (GUI) environment like Windows or Mac OS, the command line in Linux does not always make it apparent which directory you're presently in. To navigate to a new directory, you usually need to know where you are currently. The present working directory command, pwd, returns your location within the directory structure. Enter pwd in your terminal to see where you are. In this case, Linux returns /home/user, telling me I'm in the user's home directory. And because you logged in as user when you started Linux, you should be in the user's home directory, too. If you're in another directory, pwd will return that directory name instead. Checking your login with whoami. If you've forgotten whether you're logged in as root or another user, you can use the whoami command to see which user you're logged in as. Navigating the Linux file system. Navigating the file system from the terminal is an essential Linux skill. To get anything done, you need to be able to move around to find applications, files, and directories located in other directories. In a GUI-based system, you can visually see the directories, but when you're using the command line interface, the structure is entirely text-based, and navigating the file system means using some commands. Changing directories with cd. To change directories from the terminal, use the change directory command, cd. For example, here's how to change to the /etc directory used to store configuration files. The prompt changes to root at // /etc, indicating that we're in the /etc directory. We can confirm this by entering pwd. To move up one level in the file structure, toward the root of the file structure, or /, we use followed by double dots, as shown here. This moves us up one level from /etc to the /root directory. Listing the contents of a directory with ls. To see the contents of a directory, the files and subdirectories, we can use the ls list command. This is very similar to the dir command in Windows. This command lists both the files and directories contained in the directory. You can also use this command on any particular directory, not just the one you are currently in, by listing the directory name after the command. For example, ls/x shows what's in the /etc directory. To get more information about the files and directories, such as their permissions, owner, size, and when they were last modified, you can add the switch after ls. The L stands for long. This is often referred to as long listing. Let's try it here. As you can see, LSL provides us with significantly more information, such as whether an object is a file or directory, the number of links, the owner, the group, its size, when it was created or modified, and its name. Some files in Linux are hidden, and won't be revealed by a simple lsl command. To show hidden files, add a lowercase a switch, like so. If you aren't seeing a file you expect to see, it's worth trying ls with the a flag. Getting help. Nearly every command, application, or utility has a dedicated help file in Linux that provides guidance for its use. For instance, if I needed help using the best wireless cracking tool, AirCrack, I could simply type the rcrack command followed by the help command. Note the double dash here. The convention in Linux is to use a double dash before word options, such as help, and a single dash before single letter options, such as H. When you enter this command, you should see a short description of the tool and guidance on how to use it. In some cases, you can use either or to get to the help file. For instance, if I needed help using the hacker's best port scanning tool, map, I would enter the following. Unfortunately, although many applications support all three options, help, H, and there's no guarantee the application you're using will. So if one option doesn't work, try another. Referencing manual pages with man. In addition to the help switch, most commands and applications have a manual man page with more information, such as a description and synopsis of the command or application. You can view a man page by simply typing man before the command, utility, or application. To see the man page for rcrack, for example, you would enter the following. This opens the manual for rcrack, providing you with more detailed information than the help screen. You can scroll through this manual file using the Enter key, or you can page up and down using the PGDN and PG up keys, respectively. To exit, simply enter Q for quit, and you'll return to the command prompt. Finding stuff. Until you become familiar with Linux, it can be frustrating to find your way around, but knowledge of a few basic commands and techniques will go a long way toward making the command line much friendlier. The following commands help you locate things from the terminal. Searching with locate. Probably the easiest command to use is locate, followed by a keyword denoting what it is you want to find. This command will go through your entire file system and locate every occurrence of that word. To look for rcrack, for example, enter the following. The locate command is not perfect, however. Sometimes the results of locate can be overwhelming, giving you too much information. Also, locate uses a database that is usually only updated once a day, so if you just created a file a few minutes or a few hours ago, it might not appear in this list until the next day. It's worth knowing the disadvantages of these basic commands, so you can better decide when best to use each one. Finding binaries with whereas. If you're looking for a binary file, you can use the whereas command to locate it. This command returns not only the location of the binary, but also its source and man page if they are available. Here's an example. In this case, whereas return just the rcrack binaries and man page, rather than every occurrence of the word rcrack. Much more efficient and illuminating, don't you think? Finding binaries in the path variable with which the which command is even more specific. It only returns the location of the binaries in the path variable in Linux. We'll look more closely at the path variable in other lectures, but for now it's sufficient to know that path holds the directories in which the operating system looks for the commands you execute at the command line. For example, when I enter rcrack on the command line, the operating system looks to the path variable to see in which directories it should look for rcrack. Here, which was able to find a single binary file in the directories listed in the path variable. At minimum, these directories usually include /usr/bin, but may include /usr/sbin, and maybe a few others. Performing more powerful searches with find. The find command is the most powerful and flexible of the searching utilities. It is capable of beginning your search in any designated directory and looking for a number of different parameters, including, of course, the file name, but also the date of creation or modification, the owner, the group permissions, and the size. Here's the basic syntax for find. So, if I wanted to search for a file with the name Apache 2, the open source web server, starting in the root directory, I would enter the following. Results for this search are shown here. The find command started at the top of the file system, went through every directory looking for Apache 2 in the file name, and then listed all instances found. As you might imagine, a search that looks in every directory can be slow. One way to speed it up is to look only in the directory where you would expect to find the file you need. In this case, we are looking for a configuration file, so we could start the search in the /etc directory, and Linux would only search as far as its subdirectories. Let's try it. This much quicker search only found occurrences of Apache 2 in the /etc directory and its subdirectories. It's also important to note that unlike some other search commands, find displays only exact name matches. If the file Apache 2 has an extension, such as apache2.conf, the search will not find a match. We can remedy this limitation by using wildcards, which enable us to match multiple characters. Wildcards come in a few different forms, *, and. Let's look in the /etc directory for all files that begin with Apache 2 and have any extension. For this, we could write a find command using the following wildcard. When we run this command, we find that there is one file in the /etc directory that fits the Apache 2 * pattern. When we use a period followed by the * wildcard, the terminal looks for any extension after the file name Apache 2. This can be a very useful technique for finding files where you don't know the file extension. When I run this command, I find two files that start with Apache 2 in the /etc directory, including the apache2.conf file. Filtering with grep. Very often when using the command line, you'll want to search for a particular keyword. For this, you can use the grep command as a filter to search for keywords. The grep command is often used when output is piped from one command to another. I cover piping in next lectures, but for now, suffice it to say that Linux, and Windows for that matter, allows us to take the output of one command and send it as input to another command. This is called piping, and we use the command to do it. The key is usually above the Enter key on your keyboard. The PS command is used to display information about processes running on the machine. We cover this in more detail in other lectures, but for this example, suppose I want to see all the processes running on my Linux system. In this case, I can use the PS, processes, command followed by the OS, which is to specify which process information to display, like so. This provides me with a listing of all the processes running in this system, but what if I just want to find one process to see if it is running? I can do this by piping the output from pistogrep and searching for a keyword. For instance, to find out whether the Apache 2 service is running, I would enter the following. This command tells Linux to display all my services and then send that output to grep, which will look through the output for the keyword Apache 2, and then display only the relevant output, thus saving me considerable time and my eyesight. Modifying files and directories. Once you've found your files and directories, you'll want to be able to perform actions on them. In this section, we look at how to create files and directories, copy files, rename files, and delete files and directories. Creating files. There are many ways to create files in Linux, but for now we'll just look at two simple methods. The first is cat, which is short for concatenate, meaning to combine pieces together, not a reference to your favorite domesticated feline. The cat command is generally used for displaying the contents of a file, but it can also be used to create small files. For creating bigger files, it's better to enter the code in a text editor such as Vim, Emacs, Leafpad, Gedite, or Kate, and then save it as a file. Concatenation with cat. The cat command followed by a file name will display the contents of that file, but to create a file, we follow the cat command with a redirect, denoted with the symbol, and a name for the file we want to create. Here's an example. When you press enter, Linux will go into interactive mode and wait for you to start entering content for the file. This can be puzzling because the prompt disappears, but if you simply begin typing, whatever you enter will go into the file, in this case, hacking skills. Here, I entered hacking as the most valuable skill set of 21st century. To exit and return to the prompt, I press Ctrl+D. Then, when I want to see what's in the file hacking skills, I enter the following. If you don't use the redirect symbol, Linux will spit back the contents of your file. To add or append more content to a file, you can use the cat command with a double redirect, followed by whatever you want to add to the end of the file. Here's an example. Linux once again goes into interactive mode, waiting for content to append to the file. When I enter everyone should learn hackengond, press Ctrl D, I am returned to the prompt. Now, when I display the contents of that file with cat, I can see that the file has been appended with everyone should learn hacking, as shown here. If I want to overwrite the file with new information, I can simply use the cat command with a single redirect again, as follows. As you can see here, Linux goes into interactive mode, and I enter the new text, and then exit back to the prompt. When I once again use cat see the content of the file, I see that my previous words have been overwritten with the latest text. File creation with touch. The second command for file creation is touch. This command was originally developed so a user could simply touch a file to change some of its details, such as the date it was created or modified. However, if the file doesn't already exist, this command creates that file by default. Let's create no file with touch. Now when I then use lslto see the long list of the directory, I see that a new file has been created named no file. Note that its size is 0 because there is no content in no file. Creating a directory. The command for creating a directory in Linux is mkdir, a contraction of make directory. To create a directory named no directory, enter the following command. To navigate to this newly created directory, simply enter this. Copying a file. To copy files, we use the command. This creates a duplicate of the file in the new location, and leaves the old one in place. Here, we'll create the file old file in the root directory with touch and copy it to /root/no directory, renaming it in the process, and leaving the original old file in place. Renaming the file is optional, and is done simply by adding the name you want to give it to the end of the directory path. If you don't rename the file when you copy it, the file will retain the original name by default. When we then navigate to no directory, we see that there is an exact copy of old file called no file. Renaming a file. Unfortunately, Linux doesn't have a command intended solely for renaming a file, as Windows and some other operating systems do, but it does have the move command. The mv command can be used to move a file or directory to a new location, or simply to give an existing file a new name. To rename no file to no file 2, you would enter the following. Now when you list ls, that directory, you see no file 2 but not no file, because it has been renamed. You can do the same with directories. Removing a file. To remove a file, you can simply use the rem command like so. If you now do a long listing on the directory, you can confirm that the file has been removed. Removing a directory. The command for removing a directory is similar to the rem command for removing files, but with dir for directory appended like so. It's important to note that rmdir will not remove a directory that is not empty, but will give you a warning message that the directory is not empty, as you can see in this example. You must first remove all the contents of the directory before removing it. This is to stop you from accidentally deleting objects you didn't intend to delete. If you do want to remove a directory and its content all in one go, you can use the R switch after rm, like so. Just a word of caution, though, be wary of using the Roshan with rm, at least at first, because it's very easy to remove valuable files and directories by mistake. Using rmdir in your home directory, for instance, would delete every file and directory there, probably not what you were intending. Now that you have some basic skills for navigating around the file system, you can play with your Linux system a bit before progressing. the best way to become comfortable with using the terminal is to try out your newfound skills right now. In subsequent chapters, we will explore farther and deeper into our hacker playground.